Now drops and bubbles. Here we have to derive the equation for the pressure difference for bubbles. See, suppose we have a bubble having radius equal to r. Suppose the inside pressure of the bubble, that is Pi, and outside pressure, that is Po. Here always remember this thing, the pressure on the concave surface that is greater than the pressure on the convex surface. So in this particular case, we can say Pi is greater than Po. Clear? So the pressure difference at the surface, inside pressure at the surface is Pi, outside pressure is Po. So at the surface, the pressure difference is Pi minus Po. So at the surface, the force acting, that is pressure into area. So Pi minus Po into 4 pi r square. This is the force at the surface of the bubble. Now suppose we want to increase the radius of the bubble by delta r. હવે બબલની રેડિયસ જો આપણે ડેલ્ટા r ઇન્ક્રીઝ કરવી હોય તો entire spherical surface that should be displaced by delta r. It implies that now to increase the radius of the bubble by delta r, the work done, that is force into displacement. So work done, that is W force into displacement, but force that is Pi minus Po into 4 pi r square into displacement delta r. Now suppose here, due to change in the radius of the bubble, its surface area is increased by delta A. So we already discussed this thing. This work done will be stored in it in the form of energy. Now, energy stored per unit area, that is surface tension. So S, that is the energy stored per unit area. So the energy stored in area delta A, that is S into delta A, and that is our work done. So we can calculate the work done by another equation, W equal to S into delta A also. But here we have to calculate delta A, the change in surface area. So initially the radius of the sphere, means this bubble, was R. So initial surface area, that is 4 pi r square. Then final surface area, that is 4 pi. Now new radius, that is r plus delta r. So square of it. So 4 pi r plus delta r whole square, that is r square plus 2r delta r plus delta r square. This delta r square, that is very small compared to these terms. So we can neglect it. So finally we will get the final surface area, that is 4 pi r square plus 8 pi r delta r. A 4 pi ne અહીંયા multiply કરી દીધું. Therefore, total change in surface area. So final surface area minus initial surface area. So final, that is 4 pi r square plus 8 pi r delta r minus initial, that is 4 pi r square. But here this one is multiplied by 2 because for the bubble, inside the bubble and outside the bubble, air is there. Means two surfaces are free surfaces. So area is changed for inner surface as well as for outer surface both. So this one is multiplied by 2. So we can write now the total change in surface area delta A, that is this 4 pi r square cancelled, 2 into 8. So 16 pi r delta r. Now substitute this value of delta A in this equation of W. So we can write W, that is 16 pi r delta r into S, the surface tension. But if you calculate the work done by this first equation or work done by this second equation, after all work done, that is same one. So we can compare this equation and this equation. So we can write Pi minus Po into 4 pi r square into delta r, that is equal to 16 pi r delta r S. So here pi cancelled, 1 r cancelled, delta r cancelled, and 4 is 16. So 4 will be there. So resultantly we can write Pi minus Po, that is 4S upon R. This is the equation for the pressure difference in the bubble. Now here, except bubble, if we consider a droplet, then for droplet inside it there is the liquid. So only one surface is free surface, open to air. So no need to multiply by these two here. So finally your equation, that will be Pi minus Po, that is 2S by R. So for bubbles, the equation for the pressure difference, that is 4S upon R. And for droplets, the equation for the pressure difference, that is 2S upon R. Clear?